Go.
Good day, viewers. So I am AngelLieghPepito, and I have something to discuss to you that is related in mathematics. So before we will start, let's have a recap first, in which it is related to the topic that I will discuss today. So elements is the objects that are used to form a set. For example, let's assume that set A is the days of the week. So, the elements are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So, there are 7 elements in set A, which is the set of days of the week. What if we're asked to determine the number of elements in the union of two sets? So there's a principle that will help us to determine the number of elements in the union of two sets. This principle is inclusion-exclusion principle. In this principle, if set A and B are any sets, then n of union of A and B is equals to n of A plus n of B minus n of union of A intersect B. But if set A and B or the two sets are disjoint, then n of union of A and B is equals to n of A plus n of B. There are 5 steps for this principle, or determining the number of elements in two sets. Step 1. Of course, in getting the correct answer in any problem, you should first analyze it. Or, step 1, analyze the problem. Step 2, represent each set by a variable. Step 3, create a Venn diagram to illustrate the problem. Step 4, fill up the number of elements in each circle and overlapping circles. Finally, step 5, apply the inclusion-exclusion principle. So later on, we will be able to apply this principle through giving examples. Example number 1, let set A and set B be two finite sets such that n of A is equal to 20, n of B is equal to 28, and n of union of A and B is equal to 36. Find n of intersection of A and B. So we're going to find the intersection of set A and set B. This one. Okay, so in order to get the intersection of set A and set B, let's apply the steps in determining the number of elements in the union of two sets. Okay, step 1, of course, analyze the problem. Second one, okay, I'll represent each set by a variable. So our let set A is equals to 20, set B is equals to 28, and union of A and B is equals to 36. Step 3, create a Venn diagram to illustrate the problem. So here is our Venn diagram. Since we have two sets, so we have two circles. Step 4, fill up the number of elements in each circles and overlapping circles. So let's fill up our Venn diagram. So this is set A, and this is our set B. Then set A is 20, then our set B is 28. And our missing element is the intersection between the two. Last step, apply now the
exclusion principle. So since there is a union of two sets, A union of A and B is equals to n of A minus plus n of B minus union of A and B. So n of A is equals to 20 plus n of B is equals to 28 minus union of A and B 36. So 20 plus 28 is equals to 48 minus 36. So this is how much? So 48 minus 36 is equals to 12. So therefore, intersection of A and B is equals to 12. Second example.
In the survey, students were asked about their favorite subjects.
The results are as follows. 132 students like math, 163 students like science,
73 students like English,
51 students like science and English, 36 students like math and science, 38 students like math and English, 22 students like all three subjects. So let's apply the 5 steps in determining the number of elements in the union of two sets. So first step, of course, analyzing the problem. So I'll give you 10 seconds to analyze the problem, and let's work it together after the time. So timer starts now. Step 2, represent each set by a variable. So we have a 3 subjects. So let m number of persons who like math as for the number of people or persons that like science, and E for English. Step 3, create a Venn diagram to illustrate the problem. So here is our Venn diagram for this problem. Since we have 3 given sets, we have 3 circles in our Venn diagram. Let the circle be the set M, or the number of persons who like math. This circle is for the science, and this circle is for English. Step 5, apply the principle. So in order to get the intersection of set M and set E, we should subtract the given intersection of M and E to the overall intersection of the 3 subjects. So this in M, intersection of M given M and E equals to 38, and the intersection of the 3 subjects, which is 22. So 38 minus 22 is equals to 16. So our intersection of M and E is 16. in the intersection of set M and set S, we should gonna subtract the given number of elements, which is 36, and the given elements um for the three subjects. So M intersection of S is equals to 36 subtracted to the intersection of 3, which is 22. So 36 minus 22 is equals to 14. So intersection of set A and set S is equals to 14. So number of elements in the intersection of set S and set E, the same process. We should subtract the given elements in the given problem to the intersection of the three subjects, which is 22. So intersection of S and E is equals to 51 minus 22 So intersection of S and E subtracted to the intersection of the three subjects, which is 22, is equals to 29. Number of elements in set M, we should subtract it from the given elements in the problem 132 to the total of these three elements that were part of the circle or part of the set M. So 132 minus the sum of 14, 22, and 16. So the answer is 80. The same process with the set S. So 163 minus the total or the sum of 14 plus 22 and 29 that were part of the circle of S or the number or the set S. So the answer is 98. So the same process with the set E. So 73 minus the sum of these three elements, so which is 6. So therefore, the number of elements in set M or number of students who like math is equals to 80. Then who like science, so 98 students, and students who like English, so 6 students.